So, hello everyone. I'm Alexis Bridoux. Is the sound okay? Yeah, because I hear Nico. So I'm working at Carafan, and today I would like to tell you about SwiftData predicates. I did some exploration, and I wanted to let you know how they compare to CoreData and S predicate. We'll start by just defining what fetching is in this talk, so that we are all on the same page. Then we'll see some comparison between ways to fetch with SwiftData and CoreData just to compare how they behave. And finally, I'll introduce you to SafeFetching, a library I've been working on for the past 4 years to simplify fetching with CoreData. So, what is meant by fetching in this talk? Basically, if at some point in the UI you want to display a list of users, for instance, fetching is the way to ask the database to return part of its content. For instance, here the database will return an array of users that will be displayed in the database in the UI. And what will be of interest to us here specifically is when we want to filter out results with what we call a predicate. So here I would like to only get the users that have the name that starts with Marie, Marie, Maria, you get it. So this is what is meant by fetching. But now I would like to show you a few comparisons between SwiftData and CoreData to do the same fetch requests. So to start, we'll need some materials, something to work with. So let's define the same class, the user class, for both CoreData and SwiftData. For CoreData, it just inherits from NS manage object, and it has two properties, name and score, double and string. And it's quite similar with SwiftData. You just define a user class annotated with the at model macro, and then you have the two properties. Just to be clear, most of the time, the two entities will be stored similarly in the database with the same field, score, and name. This is just some stub value to get the idea. So, with that in mind, how do we use binary comparison? Very basic example when you want to compare two values. So this is how we do it with CoreData. You just write a plain old string, and you use a macro predicate, the predicate macro with SwiftData. The first thing we can see is that the predicate macro is very, um, um, I don't have my notes, sorry, it's very expressive. So you don't, it's the way you write Swift code. So you don't have to learn something new. Moreover, the string predicate is not very easy to use because do, you might write some typo in the format. So it's very error prone. And in addition to that, the thing is that Swift predicates are type safe. For instance, you cannot compare a string value with a double one. This just will not compile. Whereas for CoreData, this will compile fine. It's just a string after all. And you might get a runtime error, which might lead to a crash or just being silently ignored by CoreData. Not sure which one you prefer, but none of the both are bad. So we might think, okay, so definitely we should go with SwiftData. It has a upper end, though it might not hold when it comes to more advanced operators, such as string operators. The first thing we want to try here is to test the prefix, which has a direct equivalent between SwiftData and CoreData, with the begin Swift operator for CoreData. And of course, SwiftData has the starts with methods, which is defined on the protocol sequence, the sequence protocol, and not defined on the strings struct. So that's fine. But when you want to do the opposite, actually the ends with or the suffix method just doesn't exist yet in SwiftData. I mean, just doesn't exist in Swift at all. There is no ends with method that is defined neither on sequence, and there is no as suffix method that is supported by the predicate macro. It's very similar to the has prefix method. The macro predicate will just throw an error at you saying that you cannot use that in the macro. So that's a bummer. But maybe, just maybe, this is an edge case, and we are going to have that in a few years, maybe a few months, maybe just an example. But when you get to the contains operator, for instance, again, it has a direct equivalent with the CoreData operators, which is fine. But when you want to use some options to compare, for instance, here the case insensitive and diacritics options. Case insensitive is to tell SQLite to just ignore the differences between the lowercase and capital letters. And diacritics is to tell SQLite to ignore things such as accent or other letters decoration. So you have actually an equivalent on SwiftData to do that, which is called localized standard contains. That's fine. That exists in Swift. But when you want to have only casing sensitive operate options for the comparison, for instance, you just won't be able to use that in the macro because again, the macro says it's not supported. Although it's very, very clear what the function name does. So we cannot use that. But there is something even more cunning, which is normalized search. Normalized search in SQLite, and I think other databases, is a way to tell SQLite to compare strings bytes per bytes rather than with the Unicode norm, all of the string comparison stuff that comes with strings. It's very efficient. It can speed up search in large database up to 10 factor. And as of today, it just doesn't exist in SwiftData, which is very, very a bummer. And if you just want to know more about normalized search and other hidden gems of CoreData, I truly recommend the book CoreData from Objective-C. It's really, it can dramatically increase your CoreData usage. So that's it for strings. But there is another thing I wanted to talk to you today, which is complex types such as structs or enums. When I learned about it, when I learned that we could use that in a SwiftData model, I was very excited. Here, how we do it. If you take the plain enum, for instance, you just have to add the codable conformance to it, and then you can just use it directly in your SwiftData model. That's really great. But of course, at some point, you might want to fetch it or use it in a fetch predicate. And this is how I would write it. I think you should definitely, you might want to write it this way because that's how we write Swift code after all. And this just won't work. You have here to specify what we call the base type. So fine, I'll specify the base type since we are back to Objective-C, it seems. So here's the base type. And it might let you think that this compiled, but when you expand the macro, it will let you know that, in fact, it doesn't compile. Because when you expand the macro, you can see that this is treated as a static member access key path and not at all as an enum member access. So this will definitely not work because the macro doesn't know how to handle that. So you might try to circumvent that by being smarter than the compiler. And this will compile, actually. This will run, but as soon as you pass that to a query, for instance, in a SwiftUI view, you will get an error log message saying that, in fact, it doesn't compile. So that's really disappointing to have that in SwiftData, to be able to define an enum and just not being able to use that in a predicate. So you might tell me, or anyway, we don't have that in CoreData. But you are right, it's just not that hard to add this enum to CoreData. We'll start again with the same enum, but this time we'll make it conform to row representable. For what I'm going to tell you to work, the only requirement is that the raw value of the enum should be of one of the types that CoreData supports, strings, int16, double, you get the idea. So with that in mind, we have to define a property that is computed this time. So we'll start with the header of the property. And to make it work with CoreData, we have to add accessors such as a getter and a setter. This is what it looks like. We use what we call primitive in CoreData. This is a way to tell CoreData to write directly in the store without all the tracking and all the safety of the type that is protected by CoreData. And you might see that we are forced to typecast if we want to get the result out of it because it's any type. But most of the time, you might want to just check that the type is right, not write that like that in your code base. But it's fine for an example. You might also notice that I'm using a default value rather than dealing with optionals so that I don't have to write an optional blend value just for convenience. And lastly, since we do want CoreData to be able to track this property, we are going to add three calls, a way to tell CoreData that we are accessing the value, so a will access value, and where we are modifying that, we are calling the will change value and the did change value. So this is a way to tell CoreData that we are changing the property, we are accessing the property, so that it might work then to observe this property with KVO or with observable if you have a bridge from KVO to observable. So that's how we do it, to add an enum value to an entity for CoreData. And of course, this is a perfect use case for a macro. So this is a macro we use at Caravan. This one is not open source, boo, but definitely we could open source it if needed. And that's how it looks like in a CoreData entity. So in our user manage object, you just have to add the primitive row representable macro to your plan value and you're done. And of course, that's how you would write the predicate. Unfortunately, you still have to write strings and you have to think about using the raw value of the enum, but at least that's possible. So to wrap things up regarding SwiftData and CoreData, I think there are two major limitations with macro when it comes to the predicate macro. The first one is that a macro cannot access its outside context. So for instance, it cannot differentiate between an access to an enum, like we saw with blend.freemium, and it cannot differentiate that from, let's say, a user.current, which is completely different from an enum, which is a static member access. Macro doesn't know about that. For it's just a type and a property. It doesn't know about enums. It doesn't know about classes. It doesn't know about anything. It just know about the string you put in the macro. And the second thing is that for the macro to work, you have to write valid Swift code, meaning that if a function just doesn't exist in Swift, you can't call that in the macro. That's why we don't have yet the string ends with methods or the Swift contains method. It just doesn't exist in the Swift language and it doesn't exist in Foundation either. So if we want those functions, those operators to be available in the predicate macro, they have to be added to the Swift language or at least in Foundation. And this might not be a good idea to add functions just for the macro to work with SwiftData, which is closed source. So in conclusion, you might think that if you want to have all the CoreData features, you're stuck with string predicates. Or if you want to have the safety of Swift data predicate, you have to give up on many and several features of CoreData. Unless, of course, there is a third way. Yeah, I tried to do Smash Bros, but I didn't have quite the time. So this is the moment I introduce you to SafeFetching. That's a library I've been working on for the past 4 years with one idea in mind, which was I want to be able to write type-safe predicates that doesn't throw a runtime error at me when I give them to CoreData. Now, today, the library tries to cover three main objectives. The first one is to use type safety so that you cannot compare string and double again. And you have compiler check that will let you know that you cannot write such predicates. I also want this library to have as much as possible all the features of CoreData. And also, I want it to feel natural to write a predicate using SafeFetching when it comes to Swift syntax. If we want to visualize things a bit, we can we can draw a chart. On the horizontal line, we have all the features of CoreData. So the more you go to the right, the more features you have, and the higher you go, the more safe you are to write predicates. So this is how we could put CoreData and SwiftData. CoreData has all the features of CoreData, of course, but it's not very safe. And SwiftData is really safe, but it lacks many features that CoreData has. Whoa. Gis, c'était trop de Mac. On peut continuer sur une chaise? Ouais. Il va bien ton Mac? Il est où mon Mac? Ouais. Je vais mettre là le mien. J'ai jamais vu ça dans ma vie. Ah, c'est ça de prendre un N4 Ultra aussi, hein? C'est lourd, hein? Attends, mais regarde, je crois que ah oui, ça moi, oui, merci. Ouais. Oui. Hop. Ah oui, non, ça, oui, oui. Bon, on va utiliser la chaise peut-être en attendant. Non, mais ah. C'était prévu, hein. Il fallait un peu d'animation. C'est play, voilà. Si tu veux, c'est là. Ah. Ah oui. Ça va, vraiment, il a pas de. Alors, ça fallait que je change. Ah, c'est toi qui as saboté le pied en fait. This was planned. Not system. So it goes to buy market and then. Normalement, c'est bon. Ah. C'était ma licence. D'accord. C'est vraiment vénère, donc Bah, en fait, j'ai vu mon Mac commencer à partir et je me suis dit: «Oh merde!» et j'ai réalisé qu'en fait, c'est tout le truc qui, regardez ça sur internet, vous allez on va voir le logo de la désolé, tout va bien. Couper, couper. C'est le truc, interruption momentanée. C'est ça, il y a beaucoup plus de buveurs maintenant. Oui, j'ai l'impression, ouais. Ah oui, non, mais là, ah oui, non, c'est
Non,
parce
non,
que
elle est enclenchée dedans, donc en vrai, ça tient bien.
ah oui, d'accord.
Quand c'est comme ça, ah ouais, là, tu tombes.
Bon. Après, je peux le tenir si tu veux.
Ça doit boiter, là. Bah, une chaise en porcelaine, ça t'a compliqué. Mais je pense que c'est juste le truc qui était mal tissé ici. Ouais. Ah, à mon avis,
Contre le style. T'inquiète, t'inquiète, je vais reprendre la parce que tu non, mais t'inquiète, je vais faire next et puis voilà, ouais. C'est t'inquiète. Laquelle là? C'est celle-là, oui. Celle-ci? Non, non, juste après. Juste après? Ouais. Ça? Oui. Il y a un truc qui se traîne autour. Merci. Bah, pas de problème. Je sais que c'est difficile pour, certains développeurs de voir des Macs se faire abîmer, mais bon, c'est la vie, hein. Donc, on en était où? If we put, if we draw a chart with on the horizontal line the features and on the vertical axis the safety that we want to get, we can put CoreData here and SwiftData here. And if we do our job well with SafeFetching, it should lie around here. What does it look like? Well, basically, this is the basic example. This will request all the users in the database that have a score that is greater than 10, and then it will fetch in the NS Manage object context that you will provide if you want. But what will be of interest to us here specifically is this line. This is where we specify a safe fetching predicate. And as you might see, it's very close to the Swift syntax. It really feels like writing Swift, but it supports way more operators, such as, of course, as prefix, but the as suffix is also supported. And then normalized search is supported also. So you just have to specify an option when you want to call the contains operator. And also, if you use the enum we just saw with CoreData with the string raw value, this will compile fine and generate the NS predicate we just saw at the end of the CoreData enum. So that's the idea. And you might now be wondering how can you use that in your CoreData code base or CoreData package the way you want to? So basically, if we go back to our user NSManage object, the first required step is to make it conform to fetchable and add a fetchable member structure that will hold the two members that you want to be able that you want to participate in your predicates. So basically here you're just defining a score and a name properties that are held by a fetchable member structure that is just a way to hold the type of the property and its identifier. And once you got that, you just have to use the fetchable member static property to return that when SafeFetching needs this property to use it in predicates. Again, it's a perfect use case for a macro. So in fact, the only thing you have to do is to annotate your manage object with fetchable manage object, and it will generate everything you want. I think this approach has two major benefits. The first one is that you stay in control of what can take part to your predicates and what cannot. We saw the score and the name properties that can now be used in predicates. But for instance, you will not be able to make a mistake and use the isDeleted property on NSManage object, which will be the case with Swift, for instance, the way you write SwiftData predicates, or if you, let's say, were using KeyPass, you would be able to access any property of NSManage object. Whereas with this approach, you decide what are the members you want to see in your predicates. The other main benefit, I'd say, is that it's really easy to discover what is possible and what is not possible, whereas it is for operators, but also for the contents methods. There are also other methods to use with option sets. And it's really easy to discover because they are only defined for the fetchable member struct that we saw and not for any Swift code. So that's really easy to know what you can write and what you cannot. And in case you were wondering, you don't have to use the overall API of SafeFetching. If you want to, for instance, only use the SafeFetching predicates API, you can definitely use that with your honest fetch requests, for instance, here, by just specifying a new property, let's say, is années. So that's SafeFetching. It's type safe with compiler checking. It has all the CoreData features, at least, maybe not all, many CoreData features, at least more than SwiftData. It's a Swift package, and it comes with the Swift syntax that we are eager to write with. If you want to know, we use that intensively at Carafen, wherever it is to find a Caro key within 10,000 others in the database, or to just find the last Disney quiz score we did several weeks ago. It requires you to use CoreData. It doesn't work with SwiftData. And you have to use your own CoreData classes. You cannot use the generated classes that CoreData might do for you. So that's SafeFetching. If you want to maybe use the QR code, you can just go check it out online, and I'll go back to the other slide once you're finished. Now, if you have any questions, feel free to shoot them, and thanks for listening.
Thank you, Alexis. Do we have some questions that won't break anything? Especially those ones. Yes.
Voilà. Les deux.
So you've kind of skipped the most interesting part. I feel like, how do you generate the predicate from the Swift closure that we saw on your slide?
Sorry?
How do you generate the predicate from the Swift closure? Like, can you show us how you do it? And I'm guessing this is done at runtime, right? Every time you call.
It's all compile time. The thing is that it's performed before the compiler can even run. So the macro predicate will generate something that are called, well, it's all behind the predicate enums. So it will generate something like a builder underscore key path or builder slash function. And all of that then is converted as I think because it's mostly a wrapper or core data, it's generated, it generates NS predicate. So the very same way that SafeFetching does, but the part that splits your predicate is done at compile time, and then it just like tokenize your Swift code to make it able to be converted at runtime to NS predicate.
So can you show again the slide with where closure that you wrote?
You mean the one from SafeFetching?
Yes.
Yeah, definitely yes.
Yeah. So this one. So I don't understand. Like this is done at compile time,
Nope.
but this is not a macro.
No, it's not a compile time. I thought you were talking about SwiftData.
No, I'm talking about yours. Yours
Okay.
generates the predicate at runtime,
You
right?
don't have to know how it works, of course, to use it, but basically this is operators overload. It's
This is
only
so-
operators overload. The ID comes from Vapor. I don't know if some of you used Vapor Fluent API. I just stole the ID shamelessly, and it just works really well with. I used to use KeePass in SafeFetching. It was working well with operators overload, but it has the issue I mentioned. And also it has the KeePass had to be Objective-C marked as Objective-C. If you were using that, for instance, on a computed property, it would crash, which isn't very Catholic. That's for sure. But now with this new idea, I had to generate members with a macro. You can do anything you want. You can overload, you can add some extensions on your fetchable members to define the function you want. So it's really out of the key path, out of the entity members. It's really you keep control of what you want to see in the case. And then this zero that name as prefix is just a function that is defined on a fetchable member. The function is named as prefix, and it will just generate begins with predicate, NS predicate in that case, of course.
Yeah, so this predicate, the actual string that you pass to NS predicate is constructed at runtime, right?
Yes,
Okay,
definitely.
that was my question. Whereas
Okay.
with SwiftData, my understanding is the string is actually generated at compile time.
But both, because the builders are generated at compile time, but then the NS predicate that is sent to Swift to the CoreData SQLite store is built at runtime. It's a mix of both, I think.
Okay, thank you. So maybe my next question is like, could you go one step further and actually generate the predicate at compile time like SwiftData does?
No, I think that's the reason why I thought about that, but that's why I explained with the macro limitation is that at compile time you don't have all the things you want to properly generate NS predicate. For instance, at compile time, if you write a macro, you are not able to differentiate between an enum access to a static member access, and those are handled differently in a core data fetch request. And very similarly, if you specify an option set, for instance, there is a specific end operator, but permet, the permet. You have to use the permet operator on the option sets, but at compile time, you don't know if you have an option set or an enum or a static member access. You can't know that. You just know this is a type and this is a static member, which can be an enum case, which can be an option set or a real static member access. So there are things you can't know at compile time, whereas with this overloading of operators and extension on a specific type, you have access to everything you want because you are writing Swift code. It's not a macro.
Okay, thank you. Understand better.
There was, yes, short and last question.
You don't see any colors on the screen.
So I had another question. So do you build the fetch predicate as a string? That's the end result of the builder.
Yeah, definitely. This will actually be converted into an NS predicate with the proper format, and
Okay.
that is sent to to a fetch request, for instance.
So yeah, you use fetch request in the end. Do you use observations in the fetch request to have observability of the new object once the core data updates?
Well, this the observation is not really linked to any of the fetching.
Yeah. It's
So
the next step. Can you use it as an observation to?
well, you can use an predicate or SwiftData predicate or SafeFetching predicate for observation. Those are really completely separated things. But if you want to use observable, that's the thing we do at CoreData. I built a bridge from KVO to observable, so that you can observe an entity with observation tracking closure. Sure, but that would work without SafeFetching.
So my real question is more about do you just use the fetch predicate as is, or do you also can use it for like transient property, for example? Transient
Yeah,
property?
definitely. Well,
Or
actually,
do you
decide what you put in your fetchable member struct. So if you want to use that with a transient property, you decide to. The macro I wrote will just smartly ignore some properties that cannot be used as CoreData attributes or relationships, such as computed properties. But a transient property is it's valid to use that in a predicate, in the NS predicate, so it won't be ignored, and you can use that, or you can also use a macro variant, which is fetching ignore, to just tell the macro, don't generate a member for that.
Okay. So you're still limited by the fetch predicate and limitation.
Which are
Some transient property or like computed property, you cannot use it in a predicate because it's not updated through core data.
yeah,
It's generated once the object created.
Being able to.
Mhm.
You should not use a computed property in a core data predicate because that will crash at
Yeah.
runtime, of course, because this is core data limitation, so it's Objective C. But if you use a computed property in your LS predicates, whether it is with string or with safe fetching, it will crash. That's why the predicate macro just ignore the add fetchable member macro, ignore that when it generates the members.
So maybe it could be an improvement of your safe framework to have a next step once you get the result of the predicate to also have an option to filter member which are not filterable to a predicate.
Do you want to filter members from the macro?
Yeah, using
yeah,
the same DSL you're using, being able to do any comparison from managed object to managed property to non-managed property, and have a first step which get notified from the fetch controller, and then have another step which check the thing which are not compatible to fetch predicates.
So yeah, I did not.
We can talk about it later if you want.
Yeah, definitely yes.
Thank you, Alexis.